Welcome everybody to this explainer. Okay, I want you to think for a second about the Olympic decathlon. It is literally the ultimate test of athletic versatility, right? 10 different disciplines, 10 entirely different physical and mental challenges. You can't just be a fast runner to win. You have to throw the javelin, you have to do the high jump, you have to endure the 1500-meter race. If you're weak in even one area, you're not getting on that podium. Well, Cambridge mathematics is exactly the same. It is a high-stakes intellectual decathlon. You have to master every single type of question they throw at you: algebra, geometry, probability, calculus, to stand a chance at the very top grades. And today, we are hyper-focusing on one of the most critical, highest-stakes hurdles in this mathematical decathlon: factorial mastery. I'm telling you right now, the difference between a B and an A-star grade in syllabuses like Additional Mathematics 0606 often comes down to exactly how well you understand and manipulate factorial notation. We're talking specifically about the seemingly simple but actually incredibly deep concept of n factorial, and that golden, non-negotiable rule that 0 factorial equals 1. If you want to know exactly how Cambridge examiners differentiate the merely good students from the top-tier, absolute masters of the syllabus, you are in exactly the right place. We are going to decode the entire system. Let's get started. Consider this explainer your official examiner's playbook. Here's what we're tackling today. Act 1, the challenge. Act 2, the factorial foundation. Act 3, the method mark strategy. Act 4, an interactive workshop where you're going to put this into practice. And finally, Act 5, top examiner warning straight from the grading room. Let's decode this syllabus together. All right, let's jump straight into Act 1, the challenge. We really need to understand where things go wrong before we can fix them. To illustrate this, I want to introduce you to two hypothetical students. These two profiles represent the absolute extremes of exam panic, and I guarantee you've probably fallen into one of these traps yourself. On the left, we have Alex. Look at Alex's approach. When faced with a complex probability or permutations question, Alex just completely overloads the paper with raw mathematical facts. If the question involves arranging items, Alex writes out every single factorial expansion possible. They dump every formula they've ever memorized onto the page hoping something sticks, but they provide absolutely zero analysis. There is no connection to the specific scenario of the question. It's just a wall of numbers. Then, on the right, we have Sam. Sam's problem is entirely different. Sam is completely obsessed with the clock. Sam rushes through the reading phase and completely misses the specific command word requirements dictated by the 0580 and 0606 syllabuses. If a question specifically says, "show that," Sam just skips straight to writing the final answer. If it says "evaluate," Sam just punches it into a calculator and gives a decimal without showing a single intermediate step. Sam might actually get the final number right, but guess what? They score 1 out of 4 possible marks because the working is invisible to the examiner. Both Alex and Sam are losing massive amounts of marks, not because they're bad at math, but because they simply don't understand the rules of the Cambridge game. So, let's move into Act 2, the factorial foundation, because to fix Alex and Sam's mistakes, we cannot strategize until the underlying mathematical logic is completely flawless. Here is the core concept we are tackling today: factorial notation. By definition, n factorial, which you'll see written as an n followed by an exclamation mark, is the product of all positive integers less than or equal to n. So taking a basic example, 5 factorial is 5 times 4 times 3 times 2 times 1, which gives us exactly 120. It's the absolute fundamental mathematics of arrangements and permutations. But here, listen closely, because here is where examiners trap thousands of students every single year: the strict, undeniable mathematical rule that 0 factorial equals 1. Now you might be wondering, why on earth is 0 factorial 1? That makes no intuitive sense. Well, think about combinations. How many ways can you choose 0 items from a set of 0 items? There's exactly one way to do it: by doing nothing. It's what mathematicians call an empty product. Let's look at it algebraically. Think about the combinations formula, NCR. It's n factorial divided by r factorial times n minus r factorial. What happens if you want to choose n items from n items? The formula gives you n factorial divided by n factorial times 0 factorial. If 0 factorial was 0, you'd be dividing by 0 and your entire equation and the universe would mathematically collapse. Examiners absolutely love testing this because it immediately separates the students who just mindlessly memorize sequences from the students who truly grasp mathematical conventions. When you are simplifying complex algebraic fractions involving factorials, knowing that 0 factorial equals 1 is absolutely essential for securing those vital method marks. If you write 0, your entire cascading calculation just crumbles.
Look at this quote directly from the Cambridge syllabus documents. It says, "Top-performing students exhibit connected, conceptual understanding transferable to unfamiliar contexts." I really want you to internalize that core philosophy. Rote memorization isn't enough anymore. Alex memorized everything, remember? But Alex couldn't apply it. You need a deep, conceptual understanding to tackle unfamiliar contexts. When Cambridge throws a weird, hybrid question at you, maybe they combine factorial notation with binomial expansions or perhaps complex probabilities, they aren't just testing your memory. They are actively testing your ability to transfer what you know into a completely alien scenario. That flexibility, that adaptability, is exactly what earns the A-star.
Which brings us nicely to Act 3, the method mark strategy. So we know the math, but how do we actually demonstrate this connected understanding on paper to guarantee points?
Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's look at a framework usually reserved for English or history essays, but which is actually a secret weapon in mathematics, the Peel framework. Point, evidence, explanation, link. Now, how on earth does this work in a complex 0606 additional mathematics paper? First, the point. This is where you explicitly state the mathematical principle or formula you are about to use. For example, explicitly writing down the combinations or permutations formula on the page before you do any calculations. Don't leave the examiner guessing. Second, evidence. You extract the exact values from the word problem and substitute them into your formula. Show the raw input. Third, explanation. This is your step-by-step algebraic manipulation. This is where you explicitly show your work. For example, you need to show exactly how n factorial divided by n minus 2 factorial simplifies smoothly, step by step to n times n minus 1. Don't skip straight to the simplified form. Finally, the link. You tie your final numerical answer directly back to the specific context of the question. You don't just write 120 and draw a double line under it. You write, there are 120 unique ways to arrange the committee. This structure makes your logic completely bulletproof.
Let's break this down into a standardized procedural sequence that you can deploy on literally any Cambridge paper. Step 1. Identify key elements. What is the given data? What are the constraints? If the question says without repetition, that is a massive constraint you must flag immediately. Step 2. Apply relevant principles. Which mathematical formulas actually apply to this specific data set? Step 3. Execute with clear working. This is where you actually perform the calculation, line by logical line, maintaining a downward flow on the page. Step 4. Verify results. Now this is crucial. Does your answer make logical sense? I see this all the time. If you calculate that there are 0.5 ways to arrange people, or a negative probability, you know you've made a mistake. Stop and go back. Step 5. Present in appropriate format. Use the correct units, the correct significant figures, and the correct mathematical notation. I cannot stress this enough. Examiners actively award method marks for this exact clear working process. Even if your final answer goes slightly awry due to a simple calculator typo in the last 10 seconds, if your process is visible and correct, you keep the majority of the marks.
Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, welcome to Act 4, the interactive workshop. It's time to put all this theory into practice. Imagine you are sitting in the exam hall right now. The clock is ticking, and a complex problem appears on the page. When you face that problem, I want you to run this specific 3-step software in your brain. Deconstruct, solve, and evaluate. First, deconstruct. You are scanning the data, extracting the core trend, highlighting the specific numbers, and defining the scope of the problem. Don't just start writing. Plan your attack. Then, solve. You break the problem into systematic, logical steps. You write down each stage clearly so the examiner can follow your exact thought process. If you have to find an intermediate value, label it. Finally, evaluate. You step back and check for reasonableness. Justify why your answer fits the real-world scenario proposed in the question. Does a speed of 4,000 meters per second make sense for a bicycle? No. This 3-step process is the difference between blindly crunching numbers and actually performing high-level mathematics. Look at the comparison here to see what I mean. On the left, we have a generic answer. It's just a raw block of numbers floating in space. It says 7 factorial divided by 3 factorial equals 840. There is no context, there is poor formatting, it literally looks like scratch pad work. This is exactly our friend Alex's approach from earlier. If you make a mistake here, the examiner can't give you any partial credit because they have no idea what you were trying to achieve.
Now, contrast that with the right side, the context-specific answer. It has clear headings, it uses exact mathematical terminology, the numbers are linked directly to the scenario, it explicitly states, number of possible arrangements for the engineering team equals 7 factorial over 3 factorial, which equals 840. You can see exactly how data interpretation skills and proper presentation are critical for success. The examiner doesn't have to guess what the student was thinking. The logic is laid out perfectly on a silver platter. That is an A-star answer.
And you have to remember that when you move into the higher level papers, particularly subjects utilizing codes like 4024, 4037, and the 4040 statistics syllabus, the exam demands far more than just baseline calculation. These higher order assessment objectives demand evaluation of alternatives, comparison of approaches, and justified recommendations. If the question asks you to compare two different statistical models or probability outcomes, you must use comparative connectives. You absolutely cannot just list the features of Model A and then separately list the features of Model B and hope the examiner connects the dots. You have to explicitly state things like, Model A provides a higher number of permutations, whereas Model B restricts the outcomes because of condition X. This explicit comparative analysis is exactly how you unlock the highest mark bands.
Let's move into Act 5, Top Examiner Warnings. Every single year, Cambridge publishes Principal Examiner Reports. These documents are absolute goldmines of information detailing exactly where students globally lost marks. Let's look at the real-world pitfalls. Here are the top 3 examiner warnings pulled directly from those reports. Mistake number 1, confusing cause and effect. Students very often write equations that imply one step causes the next incorrectly. When expanding factorials algebraically, mixing up your n and n-1 terms leads to a complete breakdown in logical flow. Your math must tell a sequential, historically true story down the page. If line 3 doesn't mathematically follow from line 2, you lose the method mark. Mistake number 2, forgetting format and presentation conventions. This includes leaving final answers in improper fractions when decimals are explicitly requested, ignoring 3 significant figure requirements, or failing to use the required notation. It's heartbreaking to see a student do the hard calculus or probability work only to lose the final mark because they didn't round correctly. Mistake number 3, answers lacking specific scenario context. As we've discussed repeatedly today, this means writing down a naked number without explaining what that number represents in the context of the word problem. Let's amplify that last point right now, because it is arguably the most common error worldwide. Quote, examiner alert, the classic mistake is providing generic answers, not specific to the question context. Always link every point to the given scenario. So the crucial takeaway here is that every single mathematical step must be linked directly back to the specific context of the question. You are never just solving for x in a vacuum. You are solving for the number of hours a machine runs, the velocity of a particle at 3 seconds, or the number of distinct ways to arrange a chessboard. Ground your abstract math in the physical reality of the question prompt. Okay, let's tie all of this together into your final success blueprint. These are the 3 absolute rules that guarantee top marks and form your complete mathematical answering system. Number 1, command word decoding. Always start by highlighting the command word. Is it solve? Is it show that? Evaluate or compare? Your entire mathematical strategy changes based entirely on that one word. Number 2, PILL framework application. Point, evidence, explanation, link. Structure your math like a logical legal argument to guarantee you scoop up every possible method mark along the way. Number 3, time management matrix. Do not, under any circumstances, spend 10 minutes on a 2-mark question. Allocate your time based strictly on the marks available and move on if you get stuck. You can always circle back later. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCS and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here. I want to leave you with one final provocative thought today. Knowledge is only potential power. Actual application is power. Looking ahead to your very next study session, how will you consciously adapt the deconstruct, solve, evaluate framework we discussed today to completely conquer your next past paper? Challenge yourself to not just write down the answers, but to meticulously engineer them for maximum marks. Keep practicing, stay focused, and use these strategies to dominate your Cambridge decathlon. See you next time.